Want to do today is take a look at what happens when our ionic compounds get more complex. So we're going to start with a compound like this. If we take a look at this, we have Al2, CO3, and 3 outside of it. It looks much more complex at first glance, and you might say, how do I deal with all this stuff over here? What do I call that? How does it work? And what we have to recall is that the CO3 actually comes from something we were doing in our past unit. If you recall, we had CO3 with a negative 2 charge as one of our compounds or one of our molecules that we were drawing and working with in our last unit. So at that point we just said that these molecules form molecular bonds and they had to have a charge to them to make them work. At that point, we didn't really talk about where does the charge come from and what does that charge do to this molecule. In reality, what happens is, because this molecule is charged, we have a charged molecule, that molecule would then bond to a metal and form an ionic compound. So what we have is we still have a positive and a negative to our normal molecule. We still have our positive side and our negative side, but now our negative is just a bigger ion. It's not a single ion, it's now what we call a polyatomic ion, which is a group of atoms put together to make up the ion. Okay? So the goal today is to get to working with polyatomic ions and how they play a role in this naming system, because a lot of the chemicals we work with have these polyatomic ions in them. So to do that, first of all, let's kind of go through some of the definition stuff. Poly means many, atomic means atom, so polyatomic ion means you're getting an ion from many atoms put together. So this grouping, the CO3, this whole group acts as one item. And that whole group has a charge of -2 to it. So when you're doing naming and working with these, you treat this as a single thing, as a package deal. So this whole package works as one thing in our system. Okay? Now, when it comes to naming them, we had to be able to distinguish the difference between carbon by itself and carbon bonded to oxygen or these polyatomic ions. So when we work with polyatomic ions, if you had, let's say, just nitrogen, we would call that nitride. But if you have NO3 that's in a polyatomic ion with the 1- charge, we call that nitrate. So the change here is our ending goes to ATE. If you had NO2 with a 1- charge, we have nitrite. So nitrate and nitrite are similar, but they're different by 1 oxygen. Okay? And that pattern repeats itself with all the different polyatomic ions. So your simple anions, we end in "ide." Your standard polyatomic ions end in "ate." And then a polyatomic ion that has 1 oxygen reduced from it ends in "ite." Okay? So we get these different endings on those. Now, we have some exceptions to that. 3 exceptions to polyatomic ions that you will come across very commonly. Hydroxide is a polyatomic ion OH. It's different than the ones that we're going to see normally, and we don't end it with an 8 ending. We call that hydroxide. So it's one you're going to have to memorize. Ammonium is also named a little differently. And this one is on purpose because ammonium, if you look, it's our only positive polyatomic ion. So this is the only case where we're going to have a polyatomic ion that acts as a cation or is written first in a chemical equation. Cyanide also doesn't end in 8. and it has the formula CN. So if you notice, all three of these don't have a lot of oxygen in them, so they're a little bit different types of polyatomic ions, but they are three that you are responsible for recognizing as we go through our different polyatomic ions. Okay. Now, when it comes to polyatomic ions and naming them, we have to put 8 of them to memory. Okay. There really is no other way of doing it besides just purely memorizing these. So, if we go to that list, if we go to your periodic tables, on the back of your periodic tables, on the very bottom, you're going to see a small box that says common polyatomic ions. Okay, and if you look, there are 8 of them there. Those 8 you are required to memorize. In fact, you're going to have those memorized, and we're going to do a quiz on those 8 polyatomic ions on Thursday, where you come in and you'll list out all 8 polyatomic ions, their formulas, and their charges. So these 8 you must memorize. Right here. Nitrate, NO3, 1 minus. Chlorate, ClO3, 1 minus. Acetate, hydroxide, carbonate, sulfate, phosphate, ammonium. These 8 must be put to memory. Okay. Once you know these 8 and have them memorized, you can build from them, and you can actually determine a lot more polyatomic ions from that. So if we take a look at how we name these polyatomic ions, we always start with this root ending of 8. So let's go back to, or let's say for example, chlorate. ClO3 has a 1 minus charge. We call this chlorate. Okay? You've memorized this one, or this is one that you'll have to have memorized. Now, once you know chlorate is ClO3 1 minus, you can figure out a lot other ones based off of this root. So if you have ClO3 1 minus is chlorate, ClO2 1 minus, so if we reduce the oxygen by 1, we change the name slightly to chlorite instead. So your ites are always minus 1 oxygen. If we reduce the oxygen again to just ClO, we call that a hypochlorite. So we put the prefix on that tells us that we've done it twice. We reduced it twice, so it's hypochlorite. If you add an oxygen from your 8, we put the prefix per on it. So adding an oxygen, we get perchlorate on it. So what it comes down to is if you know this one, in reality, you'll also know 3 others just by knowing the system. So you do need to memorize those 8, but then from that, you have to be able to know the system that going down 1 oxygen gives you the ite, going down 2 oxygen gives you the hypoite, and that system. And we can change this for any of these. We can change this to a nitrogen, and our names, just the root of this just changes. So now, same system, same setup, but your nitrate goes to pernitrate, to nitrite, and hyponitrite. So once you learn the system, you can actually do this with any of those polyatomic ions that you've memorized, going up and down. Now, obviously, it only works for ones that contain a lot of oxygen. So your hydroxide, your cyanide, your ammonia, they don't do these. So it's only the 6 that have a lot of oxygen attached to them at the end. Okay? Now notice how the charge stays the same in every case. And it does that because as you build this molecule, it bonds differently to allow that charge to stay the same. So when you're moving oxygens around, the charge does not change. However, you can get the charge to change. Let's say we start with phosphate. Okay? So we have PO4, -3, which is phosphate. If we want to have a reduced charge on this, what we do is we add hydrogen. So if we attach a hydrogen to this, every hydrogen we attach reduces the charge by 1. So this now has a charge of -2. And we would call this hydrogen phosphate, because we put a hydrogen on it. If we put 2 hydrogens, we reduce the charge again. And then now, because this is technically a molecule, we can use a prefix in here. So because we have 2 hydrogens, we would call this dihydrogen phosphate. So the di tells us that we added 2 hydrogens to the phosphate. Okay? If we go down one more, now we're a neutral. We're now a neutral molecule, so we're no longer a polyatomic ion. So once we get to the point where we're neutral, we can't do it anymore. Okay? This now is a neutral compound that starts with hydrogen. So if you had a neutral compound that started with hydrogen, we actually would use our acid naming rules to name this compound, because it's a compound on its own. It's not an ion anymore. Okay? The same thing can happen with your sulfates. But sulfate starts with a -2 charge. So it can only add 1 hydrogen to it for a -1 charge, and we call that hydrogen sulfate. And then of course, all this stuff can be done with your ites also. So if you had SO4, if it was SO3, you now have sulfite. HSO3 would be hydrogen sulfite on it. Okay. So if you notice, the key here is starting with knowing those 6 polyatomic ions: sulfate, nitrate, chlorate, carbonate, phosphate, sulfate, and then from that we can change the number of oxygens to get to our ites, and we can add hydrogen to reduce our charge. Okay, so it's kind of a big piece of the puzzle, but once you get that all organized, you'll see that really expands the different type of chemicals out there that we can use. Okay guys, that ends this segment on polyatomic ions.